time independent wave equation. Okay, that is mainly what just up to de Broglie wavelength he proposed every material particle behaves as a matter waves. Okay, but Bonds what he interpreted wave function he just interpreted. Okay, but Schrodinger proved the wave equation for that material particle. Okay, material particle. So we'll discuss that part. Okay, so what he considered, just he considered an electron of mass m and velocity v. Okay, moving with velocity of some velocity v. Okay, after that and in a xyz direction, but we will first derive one dimension. After that we will expand in three dimensional means x y z coordinates. One dimensional means any direction, maybe particle is moving along the x-axis only. So we are considering particle is moving along x-axis. After that we will expand in three-dimensional, how it will change. Okay, if you want to solve in three-dimensional, will be complicated. So first we will solve in easy way. After that we will expand it. Okay, uh, can you hear any disturbance from my side, sir? Hello?
Yeah, no, sir.
No, no. Okay, just maybe a fan is running there. Okay, so that is derived expression. First we will see, we know in classical mechanics, classical differential wave equation, or you can say differential wave equation. Okay, that we know wave equation, but this wave equation cannot explain the motion of any microparticle. That's why we are solving wave equation for a microparticle. Microparticle means the size of the particle is atomic level. Okay, so here classical wave equation is dou square psi by dou x square. Here 1 by v square and dou square psi by dou t square. Okay, this is the general wave equation of macroscopic level, or any object or any body. Okay, so Schrodinger proposed or derived two equations. One is time independent and time dependent. In our syllabus, we have only time independent wave equation that we are going to solve now. Okay, so time independent means what? The wave function will not depend on time. Okay, time independent. So here, if you see in this equation, this term here, see, I am asking one question. Dou psi by dou t means what? Dou psi by dou t, or dou psi by dou x means what? Or what does that mean?
Actually, differentiation.
Yeah, differentiation.
This
What does it mean?
time and
Actually,
positive.
sorry, someone is saying I cannot hear clearly.
With
What?
respect to time
Depending
with
on t
respect
and
to
x.
Yeah, right. That's good. Yeah, that's good. So this wave function is depending on this position as this coordinate and this time or t coordinate. It is depending on this means what? This wave function is changing with respect to time. If you change the time, this wave function also change. If you change the position, this wave function also change. That is the meaning of dou psi by dou x, or dou psi by dou y, or dou psi by any component, any whatever component, just q or something, whatever. Okay, whatever the this meaning of what is this meaning means, the wave function is depending on this coordinate. If you change this coordinate, this wave function also changing. Here also, if you see this equation, it is depending on wave function is depending on time also, but we want time independent wave equation. So we want to eliminate this term. We don't want this time dependent term. For that, so if you solve, this is a second order differential equation. If you solve this equation, you will get the solution like, okay, like this way: psi 0 e to the power of minus I omega t. Okay, this is the solution for second order differential equation. This psi 0 is the some constant value. Okay, this is some constant. Okay, now you want to eliminate this dou square psi by dou t square. So you have to differentiate this wave function. First dou psi by dou t. Okay, with respect to time we are doing. Okay, psi 0 is constant. Okay, then you have to derivate only e to the power of minus I omega t. Okay, now if you differentiate psi 0, and what is the differentiation, this one? minus I omega and e to the power of minus I omega t, right? Is it correct or not?
Yes, sir. Yes, sir.
So now we want second order. So we will do it again. One more differentiation. Okay. Psi 0 is it is constant. Again I omega also constant. So you have to do it again. This I omega t to the power of I omega t. Okay, if you do it this one also, psi 0 minus I omega and here also minus I omega, you will get e to the power of I omega t. Okay, now from this equation, we will simplify this equation. I into I square. I square means minus 1. I square means minus 1 and here a minus into minus plus. So minus omega square psi 0 e to the power of I omega t. Okay, now we got second order differential equation. So this means what? Psi 0 e to the power of minus I omega t. You can write as psi, right? Psi is equal to this one, right? What is the solution? First one, this one. Just you replace this term with psi. Just we are replacing that one. Dou square psi by dou t square is equal minus omega square psi. Okay, this is equation 2. Okay, up to here, is it clear, everyone? Just we have taken solution and second we derivative double derivated that one double time. Okay, okay, then we'll replace this dou square psi by dou t square with minus omega square psi. So you substitute this equation 2 in equation 1, 2 in equation 1. Okay, now if you substitute that one, dou square psi by dou x square, here minus omega square psi, right? Is it okay? Then from there you can write dou square psi by dou x square plus omega square psi is equal to 0. Now we know here, sorry, here v square is there, right? Nobody is saying v square is there, right? Isn't it? Are you following or not?
Yes, sir.
Here v square term is there. So omega is equal to pi nu. We know this is angular frequency or frequency, you can say. Omega square is equal 4 pi square nu square. Okay, just we will replace here omega square. Okay, now dou square psi by dou x square plus 4 pi square nu square by v square into psi is equal to 0, right? Now here we know uh, what nu is equal to what? C by lambda, right? Nu is equal to C by lambda. So here you substitute that one. Nu is equal to C by lambda. In case of where it is light, if your light is propagating, this C is the light velocity. But in our case, material is propagating, right? So what we have to replace? C velocity is the C is the light velocity. Now, what is the material particle velocity? V by lambda, right? So if you replace this nu with this one, okay, just you replace here nu is there. So nu is equal, generally nu is equal to C by lambda, we know that is in case of light wave, but in our case it is material particle is propagating, a material particle is moving, so we are deriving the expression for material particle. So here you simply write nu is equal to, we are replacing C with v is the material particle velocity. Okay, just you substitute there. Okay, substitute there, dou square psi by dou x square 4 pi square nu square, or you can write v square by lambda square. Okay, v square by lambda square. Here v square is there, right? Into psi is equal to 0. Okay, just we are replacing nu with v by lambda. Okay, now what is the expression? Next expression, here v square get cancelled out, right? 4 pi square by this v square cancel out, isn't it? By
Yes.
lambda square into psi is equal to 0, right? Now we know what is the wavelength of material particle. Lambda is equal to h by mv, h by mv. So here lambda square means h square by m square v square, isn't it? Just you substitute this lambda
Yes,
square here.
sir.
Dou square psi by dou x square and 4 pi square Just I am directly writing here m square v square you get, right? Here h square, isn't it? Just I am replacing 1 by lambda square is equal to m square v square by h square is equal to, this one is equal to 0. Now up to we got here. Okay, this is expression. Maybe let's take 3, or you can directly write also. Up to now we got a expression in terms of velocity m square v square and h square. Now we know total energy is equal to what? Any particle. We want to derive the expression in terms of potential energy and kinetic energy. Okay, if particle is moving means that is having some kinetic energy. Suppose if it is having some height means it is having some potential energy. So, or if you can write half kx square means potential energy also, right? This is also potential energy. If it is the displacement, this is the displacement in a, but this is the, we cannot apply in microscopic level. So leave it this one. Okay. Now I will keep it as it is. Okay. Here see V is equal kinetic energy plus potential energy. Potential energy. Now we know if particle is moving means what is the velocity kinetic energy of mv square. Our microparticle is moving with velocity and this microparticle is having mass m. Okay. Now potential energy we don't know. Let's keep it this as it is. Okay. This is potential energy some v. Okay. Don't confuse this. You write here small v. Here you write capital V. Okay. Then there is no confusion. So E is equal this much. Okay. Now we will write half mv square is equal to E minus V. Can we write like this? You can write it, right?
Yes, sir.
So half mv square is equal to 2 into E minus V. Okay. Now in the expression equation 3, we have m square v square. But here mv square is just you multiply with m both side. Okay. M with both side. 2m capital E minus capital V. Okay. Now you this expression, let's take 4. 4 you substitute in 3 expression in this expression. Okay. In this expression you replace m square v square with 2m E minus V. Okay. You got it, right? Dou square psi by dou x square plus what is the value here? 4 pi square pi 4 pi square by 4 pi square m square v square means 2m E minus V, right? 2m E minus V. V minus V. This is capital E. Let's take that is potential. Okay. Here h square is there. So our job is completed here. Okay. Now you can rewrite this expression dou square psi by dou x square plus 8m pi square or 8 pi square m, or you can write this way also, whatever. It's you can write any way, that is not a problem. Okay. 8 pi square m by h square E minus V. E minus V into psi is equal to 0. Psi is equal to 0. This is Schrodinger time independent wave equation. Here no time term is there. No time term is there. So this is the Schrodinger time independent equation. Or you can simplify this one. H cross is equal to what? H by 2 pi, right? H by 2 pi. Now here 1 by h cross square is there. So you can h cross square is equal h square by 4 pi square. Okay, just it is in reverse. Okay, just I am writing this one dou square psi by dou x square 2m E minus V by h cross square. Can I write like this? Is equal to
Yes,
0.
sir.
Just I am writing replacing h with h cross, h with h cross. Okay, this is the time independent Schrodinger wave equation. Okay, this is in one dimensional, right? This is only in if suppose particle is going only x direction, this is the expression. If it is particle is propagating in 3-dimensional xyz components, it is the wave equation is depending on xyz component. You have to write 3-dimensionally. That means dou square by dou x square plus, or you can write psi here, dou square psi by dou y square plus dou square psi by dou z square. Here 2m. This energy, potential energy is same. This will not change. Okay, h cross square is equal to 0. H cross square psi is equal to 0. This is one dimensional. This is one dimensional, and this equation is three dimensional. Or you can write this is simple way. Simple way you can write del square psi plus 2m e minus v. This is potential by h cross square is equal into psi is equal to 0. Here del square means what? Here del square means dou square psi by dou x square, dou square by dou s square, and dou square by dou z square. This is del operator, or you can write this way, or you can write this way. This is the time independent Schrodinger equation. This equation as the function of energy, it will depend on energy and potential, and also it is depending on only position only. There is no time. There is no time. Okay. So, did you understand this one, everyone?
Yes, sir.